In Statistics 1, Chapter 8, Section 3, we will continue our discussion of hypothesis testing. So in Section 8.1, it was an introduction to hypothesis testing. In 8.2, it was, so here's kind of what we've done. 8.1 was an intro to hypothesis testing. 8.2 was hypothesis testing for proportions, P's. 8.3 is hypothesis testing for means. And then 8.4, which will complete Chapter 8 for us, is hypothesis testing for sigmas. Proportions, means, standard deviations. So we look at how to do tests for each type. So here's where we are today. Hypothesis testing for means. So problem 21 states 28 different video games showing alcohol use. So first, mostly today is about identifying numbers with the right variable. So 28 would be n, the sample size. The duration times of alcohol use in these video games in seconds were recorded when using this sample for a t-test. So we studied that back in Chapter 7. Of the claim that the population mean is greater than 81 seconds, what does DF denote? So DF is called the degrees of freedom. And it's a measure of how much variation we can have in the data. And it's a very simple equation. It's just n minus 1. So you take your sample size, in this case 28, you subtract 1. So the degrees of freedom for this problem are 27. And what does DF denote? It is the number of degrees of freedom. Now let's add a little bit to this problem. So a big part of this chapter is identifying what's your null hypothesis and what's the alternative. And we talked in 8.1 what these mean. The null hypothesis in these problems is going to be that the mean is equal to some number. So in this one, they're arguing the mean is something related to 81 seconds. Their claim is that the mean is greater than 81. So this would be mu greater than 81, and that's their claim. So we don't need that for this problem, but it's good practice because we're going to have to set this test up, this hypothesis test up for many problems throughout this section. Okay, 22, I'm actually going to skip and come back to it. So let's go to 23 for now. The display provided from technology available below results from using data for a smartphone carrier's data speeds at airports to test the claim that they are from a population having a mean less than 6. So less than is less than symbol. Conduct the hypothesis test using these results. Use 0.05 significance level. So this tells us alpha is 0.05. And what I had said last time is true again today. The null hypothesis, H0, will always use an equal sign for R course. So this one right here is wrong. And we can throw it out right away. Now this says less than, so I need equal sign on top, and I need less than as the next symbol, which means it has to be this one, B. In fact, their claim is lined up with the less than symbol. So their claim is the alternative hypothesis. Okay, problems like this, when they give you the printout, and this is how I would do it on a test too, because you can't obviously use Statcrunch on the test, and that's what I've been teaching to get these numbers. It's pretty simple. So the test statistic in this problem is the t number. So this t number here is the test statistic. They want us to round to 2 decimals, so we'll call it minus 3.76. The p-value is the thing with the p. So p equals this. To 3 decimals, it would be 0, 0, 0. And always in these problems, the last step is to compare the p-value to alpha and see which is bigger. So our p-value is 000. Our significance level alpha we wrote as 0.05. So we're just going to compare those two. And 0.05 is bigger than 0, so this is a bigger than symbol. Whenever the p-value is smaller than alpha, we always said, so this goes back to 8.1, and we built a little table for this. If it's less than symbol, then you always reject H0. So we are going to reject H0. There is blank evidence. So this is where you have to do a little thinking. If I'm rejecting H0, that means I am supporting their claim. So I'm basically saying reject this, and therefore I'm going to support the alternative. So there is sufficient evidence to support their claim. So it looks like there's evidence here that the data speeds at these airports, the mean data speed is less than 6 megabits per second. And that's basically how we do all these problems. We pick the right test. We have a test statistic and a p-value, and then we check the p-value against alpha, and then we either reject or fail to reject the null. Okay, let's try 24. It should be similar. A data set includes data from 400 random tornadoes. So N is 400. The display from technology available below results from using the tornado lengths, miles, to test the claim that the mean tornado length is greater than, so greater than is greater than symbol, 2.4 miles. Use 0.05 significance, so alpha is 0.05 again, to test the claim. So just like before, H0 should always use an equal sign, so we can throw out B. And then the second symbol we want is greater than. So we're looking for equal to and greater than has to be D. And again, their claim lines up with the alternative, that the tornado mean length is bigger than 2.4 miles. Okay, they labeled it slightly different, but it's still a T that you're looking for. So they called it T-stat in this particular. And oh, by the way, they gave you the answer to the first part. So they said mu equal 2.4, mu greater than 2.4. And so this one to 2 decimals would be 0.83, 0.83. The p-value also labeled very easy to find, p-value. To 3 decimals would be 0.204, 0.204. And that's all we need. So the last step is compare the p-value, 0.204, to the alpha value, 0.05, which is bigger. Clearly 0.20 is bigger than 0.05. Now this is different. So this points in a different direction than the last one. If ever your p-value is bigger than your alpha, you always fail to reject H0. So this one would be fail to reject H0. So if we're not rejecting H0, we always stick with H0, and then the only time we leave it is if we reject it. So if we're failing to reject this, we are staying here. We're staying with this idea. Therefore, we are not supporting their claim. So if we're sticking with this one, we're not supporting this one. So we are not going to support their claim. Or another way to say it is, there's not sufficient evidence to support the claim. So there's not sufficient evidence to support that claim that tornado mean miles is greater than 2.4. Okay, so that one's pretty, hopefully straightforward. They gave you all the answers you needed. You just had to do that comparison, which number is bigger, and then know what that means. Fail to reject or reject. 25. In a test of the effectiveness of garlic for lowering cholesterol, so we've seen this problem before, and 49 subjects were treated with raw garlic. Cholesterol levels were measured before and after the treatment. The changes before minus after in their levels of LDL cholesterol have a mean of 0.6 and a standard deviation of 23.2. Use a 0.05 significance level to test the claim that with garlic treatment, the mean change in LDL cholesterol is greater than 0. So we have a greater than symbol here, and 0 is the number of interest. So again, our null hypothesis should always have an equal sign. So we can toss out D. And the next symbol we need is greater than 0. So it's got to be B. And their claim was what? The claim was that it's greater than 0. Okay, now in this one, they do not give you a table to find the test statistic and the p-value. So we have to use Statcrunch for this problem. So let me give you those steps. Now there is no data to click on in this problem. So to access Statcrunch, you actually have to go to question help in the top right of the screen. And then you'll select Statcrunch. You'll click on the stat button. We are doing T-stats today. So you'll select that option. We have one sample. And you'll say with summary. Because we don't have data, we have summary information. And then it's going to have a box. So there'll be a box that says sample mean. Which is X bar. Well, in the problem, it says that the mean is 0.6. So X bar is 0.6. That's what we're going to type in this box down here. So we're going to type that 0.6 right here. Then it's going to ask for the sample standard deviation. Sample, it's going to say STD period, DEV period, and it's going to have another box. Well, the sample standard deviation is S. And in this problem, it told us this standard deviation was 23.2. So that is S. And that's what we'll type in this box right here, 23.2. And then it'll ask for the sample size. And it'll give us another box for that. Well, sample size is n, and we captured that right away as 49. So we'll type 49 right in this last box. Okay, then there'll be a little section that says hypothesis test for mu, the population mean. And in that, you have to just get it to match what your answer was for part A. So we have to make it look just like this. Mu equals 0, mu bigger than 0. So we'll do mu equals, in this box, you'll have to type 0. And then HA, oh, I did this last class too. It'll be H0 mu equals 0. And the alternative is that mu is this. If you type 0 here, it will auto-populate down here. But then you have to pick the right symbol here. So it's either greater than, less than, or not equal to. In our case, you have to select greater than symbol. So you will select greater than. And once you have all that set up like that, you just hit compute. And then it will spit out the numbers we need. So the two numbers we need, it'll give you more than you need, but it'll give you a table where it says t-stat. And somewhere else in the table, it will say p-value. Those are the two things we need. And for my numbers, we would get 0.181 and 0.4286. And they want us to round the t-stat to 2 decimals, so we'll call it 0.18. And they want us to round the p-value to 3 decimals, so we'll call it 429.429. Okay, the last step is always compare this p-value to alpha. Alpha in this problem was again 0.05. It doesn't always have to be that, but that is a common number. Our p-value in this case was 0.429. And clearly 0.42 is bigger than 0.05. If the p-value is greater than alpha, you will always fail to reject H0. So we are going to fail to reject this. Now their claim, if we're failing to reject this one, we are staying here. So you always stay with H0 if you don't reject it, which means we are not supporting their claim. So if we fail to reject H0, we're staying there, which means we're not jumping down here with their claim. So we would say there is not sufficient evidence to conclude that the mean difference, so there is not sufficient evidence to conclude that the mean of the population of changes is greater than 0. So their claim is that it's greater than, but we are not supporting that. Any questions on that one? Okay, so these steps are really important. We're going to use them, I think, in the next 2 or 3 problems. So hopefully you have those steps down. Let's go to 26. A simple random sample of 10 pages from a dictionary is obtained. So the number of words defined on those pages are found with the results n equal 10, x bar equals, there's 53.8 words on average for each page. And the standard deviation of pages is 16.3. Now this is nice. They gave you the numbers and the symbols. So when you have to type these into the Statcrunch, it's easy because they already gave you the number and what symbol it's matched to. So this will be the same steps as number 25 in Statcrunch to get the answers. And if you run it through Statcrunch, well, before we do that, let's figure out what the right hypothesis test is, knowing that we can throw out D because D did not use an equal symbol for the H0. So D's out. Let's see what it would be. Given that this dictionary has 1,488 pages with defined words, the claim that there are more than 70,000. So the claim is a more than or a greater than symbol. More than would be greater than symbol. 70,000 defined words is equivalent to the claim that the mean number of words per page is greater than 47. So greater than, same thing. So we're looking for equal on top and greater than on bottom, 47. So C. So you'll type X bar is 53.8, S is 16.3, N is 10. You'll make your symbols match this. You'll type in 47, you'll pick the greater than symbol, you'll hit compute, and it should spit out for you the test statistic for this one was 1.32, and the p-value is 0.111. .111. Alpha in this one is different, 0.01. So the alpha is 0.01, but either way, 0.01, 0.05. This 0.11 is bigger than 0.01. If p-value is bigger than alpha, you always fail to reject H0. Oh, we should have written their claim. Their claim was that the average number of words per page was bigger than 47. So just like before, if we're failing to reject H0, we are staying there, which means we are not going to support their claim. So to get these bubbles right, we would say fail to reject, not sufficient evidence to support the claim that there are more than 70,000 defined words in the dictionary. Okay, let's go back to 22 that we skipped. We skipped it because we need to use Statcrunch steps that I just showed you. So those Statcrunch steps in 25, we're going to use those again for problem 22. It says use technology to find the p-value for the hypothesis test described below. The claim is that for a smartphone carrier's data speeds at airports, the mean mu is 16 megabits per second. The sample size is n equals 15, and the test statistic is t equals minus 2.164. So they are saying H0 mu is equal to 16. The alternative is that mu, so if this is 16, this is 16. If this is mu, this is mu. The question is what symbol goes in between these two. The claim is for smartphone carriers data speeds at airports, the mean is 16 megabits per second. So their claim lines up with the null hypothesis. Now notice there are no words in there that says greater than or less than, more, fewer. So if there are no words like that, then the symbol we use here is not equal to. So it could be 16, it might not be 16, it could be bigger, it could be smaller, we don't know. So you're going to have to set up this in Statcrunch. So you're going to have to type 16 and use the not equal to symbol. So in Statcrunch, you'll use 16 in this box, you'll use not equal to in this box. So this is going to be the same steps as number 25 for Statcrunch. There is one more wrinkle though. So they gave you sample size. We do not know X bar and we do not know the standard deviation S. So to do this problem, you're going to assume S equal 1. So you'll type that in Statcrunch. So you'll type the sample size is 15. The standard deviation is 1. But that leaves X bar. So here's how you get X bar. This T statistic, which they gave us, is equal to X bar minus mu over S divided by the square root of N. We know mu, 16. We know S, we're assuming it's 1. We know N, it's 15. We know T, it's negative 2.164. So the only unknown here is X bar. So using algebra, we can solve this equation for X bar, and I'm just going to give it to you so we don't have to paint our way through algebra. X bar is equal to the T value they gave you times S over the square root of N plus mu. So for our problem, the T they gave us was minus 2.164. S we assumed to be 1. N was 15. And this mu was 16. And if you get this right on your calculator, it's not necessarily the simplest thing to type in, but if you do it, you should get X bar is 15.44. So if I type this in Statcrunch, S is 1, N is 15, set up this H0 and HA, it will spit out a p-value for me of 0.048 with those numbers that I had. There are ways to do this without Statcrunch, but I think it's much easier to do Statcrunch. So for your problem, when you see this in the homework, you just have to plug your numbers into this formula, and then you can plug these 3 numbers in and it'll spit it out. Okay, that takes us to 27, I believe. Assume that a simple random sample has been selected from a normally distributed population and test the given claim. Identify the null alternative and the p-value and everything else. A safety administration conducted crash tests of child booster seats for cars. Listed below are results from those tests, with the measurement given in head injury unit, HIC. The safety requirement is that the head injury condition unit measurement should be less than 1,000. Use a 0.05 significance level to test the claim that the samples from a population with a mean less than 1,000. So that word less than, when we see that, that means we're looking for the less than symbol. And we know H0 should always have an equal, so I can eliminate these two. And so I want equal on top, less than on bottom. It's got to be B. And their claim is with the alternative, the less than. Okay, now this one, they gave us actual data. So this is the data. So the steps in Statcrunch become slightly different. So you're going to do these steps. So let me give you these new steps. Again, you'll go to question help. And you'll click Statcrunch. And then you have to type the data in column 1, which they call variable 1 in Statcrunch. So you're going to actually type these 1, 2, 3, 4, 5, 6, 6 numbers in. So you'll type 722, then 738. You'll type those going up and down in this first column. Once you have those typed in, then it becomes pretty easy. You'll select stat. Again, you'll select tstat. You'll say 1 sample. This time you'll say with data. So now we have the data to use. And you'll click variable 1 because that's where your numbers are stored. Then you'll set up your hypothesis test. So you'll go in there and say H0 mu is equal to, in this case, we'll match it exactly as to here. So we'll say it equals 1,000. So you'll have your box to type in your number. The alternative, this 1,000 will pop down here. The alternative has a selection for the symbol, and our symbol is less than. So you'll pick less than, and then you'll hit compute. So it's actually even fewer steps than the other problem, because it's going to go in and find the mean and find the standard deviation and find n. It's going to find all that stuff for us based on those numbers. So less work for us. And if you do this, you'll get a p-value of 0.0109 to 4 decimals. And the t statistic you'll get is negative 3.290. Okay, P alpha. So we always compare the P to the alpha. Alpha in this problem was 0.05. So we have 0.05. This one is smaller. 0.01 is smaller than 0.05. So that's one of those. We haven't seen a lot of these. If P less than alpha, you will always reject H0. So we are going to reject the null. If we reject the null, so we're rejecting this one, that means we're jumping down to this one. So we are going to support their claim. So if we reject H0, that means we have to be supporting their claim. So there is sufficient evidence to support the claim. So what do these results suggest about the child booster seats meeting the specified requirement? There is strong evidence that the mean is less than 1,000 head injury condition units, but one of the booster seats has a measurement that is greater than 1,000. So part A says it best. You just have to be careful. You might want to know what booster seat that one is, because it technically doesn't meet specifications. But you can see the other ones all are well below 1,000. Okay, that's it for the kind of the stat crunchy ones. The last three are more theory. So let's take a look at those. Should be a little simpler to do. 28. For a hypothesis test of the claim that the mean amount of sleep for adults is less than 9 hours. So note here, their null would have been that the mean sleep is 9 hours. The alternative is that people on average are getting less than 9 hours. That is their claim. Less than 9 hours. Technology output shows that the hypothesis test has power of 0.4516 of supporting the claim that mu is less than 9 hours of sleep when the actual population mean is 7.5 hours of sleep. Interpret this value of the power, then identify the value of beta, interpret that value. So I can't remember which section it was, maybe chapter 7 even, we said power was equal to 1 minus beta. But I don't think I had stated what power really meant. I stated it, but let me state it a different way. Power is equal to the probability of recognizing the true population mean. So notice in this problem, they told us the power is 0.4516. Well, that's a probability. So what this means is there's a 45.16% chance of recognizing the true amount of sleep people get. Does that feel like it's a good probability? So literally a coin flip could do a better job, right? So a coin flip could do a better job of predicting the true amount of sleep people get. So this is very low. This is a very low power. So the chance of recognizing that mu is less than 9 is not very high, when in reality, mu is 7.5. So we kind of know that the actual average amount of sleep is 7.5 hours, but we only have a 45% chance of realizing that. So that's pretty bad. Okay, now the second part says, what's beta? Well, if power is 1 minus beta, then beta is 1 minus power. You can literally just swap those two. And we know that our power was 0.4516. So in this one, beta should equal, just subtract those two numbers, 0.5484. And beta is another probability. This is the probability of failing to recognize the true mu. Probability of failing to recognize the true mu. So in this case, we have a 54.84% chance of failing to recognize the true mean amount of sleep. Also pretty bad. So if your power's low, your beta's high, both are bad. You want a high power and a low beta. So these are kind of both showing the same thing. And the best answer here is B. So we'd say the value of beta is 0.5484. Indicates that there is a greater than 50% chance of failing to recognize that mu is less than 9. So let's just put that maybe down here as a formal statement. We want high power and low beta. Like you want 99% here and you want 1% here. That would be great. Okay, 29. Which of the following is not a characteristic of the t-test? So we've been using t-test all day. We've just been letting Statcrunch do the actual test. The student t-distribution has the same general bell shape as the standard normal distribution. That's true. So I had said that it looks like the t-distribution, but it changes with sample size. So the student t is different for different sample sizes. That's true. T-test is robust against departure from normality. That's true. The only one that's not true is A. It does not have to have a mean of 0, and it does not have to have a standard deviation of 1. Well, it does have a mean of 0, excuse me, but it does not have to have a standard deviation of 1. Okay, let's see, 30. Which of the following is not true when using the confidence interval method for testing a claim about mu when sigma is unknown? The p-value method, the traditional method, and the confidence interval method are equivalent and yield the same results. That's true. For a two-tailed hypothesis test with 0.05 significance level, one must construct a 95% confidence interval. That's true. For a one-tailed hypothesis test with 0.05 significance level, one must conduct a 90% confidence interval. That's also true. The only one that's not is B. The p-value method and the classical method are not equivalent to the confidence interval method in that they may yield different results. That's false. They will provide the same result. And now we'll complete section 8.3.